Hey, so we're going to do this one. And this one is a super simple one. We're going to find the possible rational zeros for this. I wish they would say possible in front of this. Possible. Because not all of them are going to be zeros. All right, so we make a fraction, all right? I'm just going to make a bunch of little ones at first. Okay, what are the factors of the last term? Remember, it was L over F. So it's factors of the last term, factors of the first term. So what? Oh, it's just 1 and 1, huh? What about -1 and -1? So I could put a positive 1 there, or I could put a -1, right? So I'm going to put plus or minus 1. And then my other leading coefficient is 1. So I put a plus or minus 1 right there. So those are our possible rational zeros. And what does this actually say? It says 1 over -1. It says -1 over 1. It also says -1 divided by -1. It also says 1 over 1. And all these simplified. This is why this one's just super easy. Okay, let's simplify this. That simplified is -1. This simplified is -1. This simplified is 1. And this simplified is 1. So really, our possible rational zeros, I'm using L and F. I don't know if I should do that. That's sacrilegious or something. P divided by Q, that's L and F. Maybe we should just keep P and Q. I don't know. I don't want to make anybody angry. Okay, we got -1 and 1. Those are the possible rational zeros. Now, how do we know if a number is actually a zero? Talk to your neighbors. All right, there's two ways. The first way, which is probably the most common way, is you just plug it in. And you see if you get a zero. So it'd be 1 to the third plus 1 plus 1. No. Already tried -1. It would be -1 to the third plus -1 plus 1. Okay, are these possible rational zeros? Are they zeros? Are they or no? Nah. This one right here equals 3, and what does this one equal? That'd be -1 plus -1 plus 1, which is -1. So we don't get 0 for either of those. The other way to do it is to try synthetic division with it. So we would have 1, and then we put in a placeholder, and then a 1, and then a 1. And you would get the same result. It's just the other way to do it. -1, -1, +1, 2, and then 2 times -1 is -2, and I get -1. So if I plug in -1, I get -1, just like up here. All right, so both of these possible rational zeros are not zeros. So I don't know. I don't know how to factor this right now. Maybe we'll have imaginary zeros with imaginary numbers. Let's do another one that actually has rational zeros. Let's find our possible rational zeros for this one. All right, remember it's L over F, or P divided by Q. That's what the book says. Okay, the L, the last, are the possible, are the factors of 6. What are all the factors of 6? You got 1 and 6, 2 and 3, and that's it, right? Yeah. So we have plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. Those are all the possible factors of 6. And then what are all the possible factors of our first one? Plus or minus 1. Ooh, thank goodness. So we have a bunch of numbers here. Now, if I were to write all these out, it'd be annoying. I would get 1 divided by 1, which would be 1. 1 divided by -1, which would be -1. And then we have 2 divided by 1, which is just 2. And then we have 2 divided by -1, which is -2. And then we have 3 divided by 1, which is 3. And 3 divided by -1, which is -3. And then we have 6, and then -6. These are all the possible rational zeros. These numbers could possibly give us a 0 if we did synthetic division or plug them straight into the function. So how do we know which one? This is the part that stinks. You don't. You have to test. Yes, you test them until you find one. Yes. Yeah. If you test it, you don't get a 0, you gotta test another one. Well, if you get one of them, then you get a smaller polynomial, and you might be able to factor it. Okay?